knowing cross cancellation is gonna save you a little time. You don't wanna have to multiply all this stuff out the way it is, just do this. 5 goes into 5 once, into 25 5 times. 2 goes into 4. 2 goes into 26 13 times. Multiply what's left, you get 2 over 65. Hence the answer. Yeah? Number 2. Tell me there if something that makes sense there, or you don't know where I got something, because I'm sure the test will be the same there. Alex figures she saved $12 buying an item at 30% discount. How much did she pay for the item? Which means you're going to do what, Evan? You're going to make a percent, which is nothing more than a glorified ratio box. Okay, this is a discount problem. So you start with an original number, you subtract the discount, and you end up with the final number. Our original numbers are always, chime in there anytime you like, 100%. The discount was 30, which means you paid what percent? 70. Now what do I know? She saved $12. Is that how much the thing cost? How much what the discount was, or what the final price was? That's how much her discount was. So it's $12. How much did she pay for the item? You just want to know the final number. And it's just equal fractions here. 30 over 70 equals 12 over what number? And if you can do this the easy way, do it. The hard way would be to use cross products. 30 times n equals that times that. But this fraction reduces by what, Sammy? So you knock off the ending zeros, and then it's just making equal fractions. 3 times what is 12? 4. So 7 times 4 is 28. That is your final price. $28. At some point, I know some of you will go, I'll hear the gasp of, oh, that makes sense.
That makes sense.
Some of you will be like, why didn't I get that the first time? Number 3, how do you know if something is direct variation, which really means proportional? Alright. Letter A, does proportion lines, if something is proportional, or direct variation means as one goes up, the other one goes up. Okay. Oops. It means, yes, it'll be a straight line. Okay. Does it have to be positive? No, it does not. Does it have to go in the second and fourth quadrants, which would be 2 and 4? Doesn't have to. Does the graph align with the, which ones? Which one is not a characteristic? Which one could be, but which one is not? What was the answer? Yeah. Now why is it? Because this one said it had to lie. Okay, that's not true. It could. It could do this. It doesn't have to, no. This is the key there. It does not have to. Okay. Number 4, image on a computer screen is increased by 50%. And again, here's what I said, just draw something simple, and most of you did. And here's, I agree, if you miss this because of the wording, I think it's probably, what can you do about it? Most of you drew these squares, right? And if you pick an easy number, you pick 10. If you increase 10 by 50%, what's 50% of 10? 5, and you increase it by that, you end up with 15. So we're talking about its area. So the area of this one is 100. Most of you got that. Area of this one is 225. Okay. Now there's 2 different questions they'll ask you on this. One of them is, what was the increase in percent? Or what? The second thing they might ask is, what percent of? This one asked for the increase in percent, which means you have to figure out how much did it go up. How much did it go up? It went up 125. It went from 100 to 125. So it went up 125 over what it started out being, which was 100. What percent is that? 125. You probably could make a ratio box out of that. But let's look at a ratio box, what it would look like. We had our original one, which was this one. We had our increase, which was 50%, right? Is our increase 50%? And our final one was 150%. Our original one was 100, right? What was the increase? Went from 100 to 125, so it increased 125. And they didn't ask us this one, which is actually 225. So this is the number you're looking for. This was your increase in percent, 125. So Grace, I think I told you 225, but I wasn't reading the problem clearly, which just goes to show you.
Mr. Han,
Whoa, what?
what was the answer again?
125. It asked you for the increase in percent. What increases by what percent? They didn't ask you for the final, is what percent of. It asked you for the increase in percent. Steamrolling here, kids. Oh, this one's my favorite one. Figure ABCD is a rectangle. Refer to the figure and answer questions 5 and 6. What are the lengths of CE, EF, and FB? Well, what is CE? From here to here. Well, again, it's a right triangle. So I go and hopefully it's a perfect triple. So that's why the thing's on the wall. Is there a 5, 12? So the hypotenuse has to be 13. What is EF? Well, here's the, whatever is the sum of its parts. 5 plus 9 plus what number gives you 20? 5 plus 9 plus some number has to give me 20. So 14 plus some number has to give me 20. So EF is in fact 6. And then what was the other one? Facebook? FB. Hopefully there's a 9, 12. Uh-oh. Now, when there's one that doesn't work out, do you walk away all dejected, Gary? What do we do first?
You see if they have the two numbers you have a common factor.
Yeah, see if these two have a common factor that you can reduce them by to see if that's a triple. Don't have to do the Pythagorean theorem right away unless this doesn't work. 9 and 12 can be reduced by 3. So I divide them both by 3, but what you have to remember is if you use, what's going on? If you divide them both by 3, when you get your answer and it works, you then have to remultiply it by 3 to get the real number. This is a 4, this is a 3. Is there a 3, 4 triangle? Yes. Which makes this side not 5. Because you divide it by 3, you have to then remultiply by 3 and you get 15 for that one there. Good for you. Christian? Any personal testimonies you want to throw out there? No. All right. And then what's the area of trapezoid BCEF? So you should write down the formula for the area of a trapezoid, which is 1/2 base 1 plus base 2 times height. Base 1, you can't see it, but I believe we said it was what? 6. So 1/2 of 6 plus what the bottom is, base 2, 20, times the height, which is, now how do I know, how come 13 or 15 are not the height? Why is 15 or 13 not the height of that thing? Smith, why is this not the height or that the height? What fundamental rule have we talked always about with shapes? When they talk about bases and heights, one thing has to be true about that for sure. Sammy? They have to form right angles with each other. So this is not a right angle, or is this a right angle? This, right here, between these two lines, are right angles. So the height has to be 12. So if I were jotting my, if you missed that on today's, that would be a thing start item I would use on my notes and say, please make sure you use the right height, which is the right angle thing. So then you end up with 1/2 times 26 times 12. And somebody asked me yesterday, it doesn't matter which one you take half of. Order of operations, multiplication can be done in any order. So if you wanna take half of this and get 13 and multiply it by 12, you can do it. If you wanna take half of 12 and get 6 and multiply it by 26, you just can't multiply both by half. Because then you multiply it by a quarter. So you gotta pick one, or you can multiply 26 times 12 and then cut it in half. Alex says, I'm going to cut 12 in half and get 6. So 26 times 6, 36, 156 centimeters, that's area squared. How many people got that wrong? I should go look. Look, I can see. What problem gave us the worst issues? Oh, problem 19. Problem 1 and 19. Moving on, how about, okay, we can do this. Number 7. The formula for the sequence is this. They told you the formula. N squared minus 2. What is the 12th? What is the 12th? What do I do with the 12th? What is the 12th? Why did they tell me it's the 12th? Calvin?
Because you put 12 in for 10.
Right, the term number you want is the letter N. So I put 12 in for N right here. You can put it in for N right there, but you don't do anything with it. It just says, this, when you do A sub 12, that just means the 12th term, which is what you're looking for. Equals 12 squared minus 2. And 12 times 12 is 144. Minus 2 is 142. 142. And then, children, this one right here. We talked about this. There are times when you have no option. 66 2/3 cannot be changed to a decimal. Okay? You can't change it to a decimal because as a decimal it's 0.6 repeater forever. You could change it to a decimal, but you can't multiply it 36 times that. Because you can't write forever 0.6s. So there are some percents that you need to recognize are perfect fractions, and that's why I gave you this thing here. You need to look at this thing here and see if one of those percents is one of the fractions that works out, because that's your only option. If it was 1/5, you could change it to a decimal, because that's 0.2. You can't change 1/3 to a decimal and work with it, because it's 0.3 repeater forever. So you should have looked at this and recognized that 66 2/3% is 2/3 as a fraction. Of is multiplication, $36. You don't need to put the decimal there or whatever, you can just do it like this. 3 goes into 36 12 times, and 2 times 12 is $24. So please, I would on number 8 for tomorrow, I put a little star there and say, hey, check your sheet and see if that works to a perfect fraction. Sometimes it's better to do decimals, but if you get a fraction that's, 11 1/9%, that's 1/9 as a decimal, as a fraction, so you want to use that. Got that? Oops,
We could use this thing.
by all means. At some point, it's my hope that you start to recognize some of them. 1/3, 2/3, 1/6 is what, 16 2/3%? What is 1/6?
16.
You should, at some point, look at, you just see it enough times. That kids, you're on some sort of a mission. If there's one of these that's way too easy, maybe we shouldn't do it. And for problem number 9, please have the volume formula for the volume of a cylinder. Okay. I think I told you that you can always use area of base times height for something. For cylinder, I'd actually memorize it. Base is a circle, so it's the area of a circle. Pi times radius, that's the area of the base, that is the circle, times the height. And again, there's that height, Smith. Height means, height has to be perpendicular to the base. So it's just going to be this, pi times radius, what's the radius? 10 times 10 times the height of 10. And it doesn't get much easier than that, because pi is 3.14 times 10 times 10 times 10, which is 1,000. Move the decimal 3 places, and it is 3,140 inches cubed. Did I do it wrong?
I have a question.
Adam?
For like the radius, how do you get to?
Because the diameter is 20. Right? This 20, Evan,
Oh!
is the diameter of this circle. If I were to draw this circle out like this is 20. Radius is always half of that, so it's 10. Got the light bulb there? And for letter number 10, lateral surface area, LSA, is the area of the sides. Lateral surface area of a cylinder, LSA of a cylinder, is the circumference of the circle, pi times diameter times the height. I would jot that down. 3.14. What's the diameter? This time isn't the radius, it's the diameter, 20. What's the height? 10. So it's 3.14 times 200, and unfortunately people didn't ask you to leave it in terms of pi. 3.14 times 200 is not that difficult of a multiplication problem. Moving the decimals, 628. And this is area, so what's my label? Square distance. We are cruising. Uh-oh, Jacob?
For problem number 10, I looked in the book and I found the area of the cylinder, or lateral surface area of the cylinder. And I did perimeter of the base times height, and I still got 628.
Yeah.
Yeah,
That's
so
what
what
we
circumference is it?
Remember the base is circumference. That's what we just, I thought I said that. Gracie?
So about the 3.14 times 200, how did you get 60?
How did I get 628? 3.14 times 200. Drop the 2 zeros. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. 2 decimal places, 628. Now, here comes some fun and exciting stuff. There should be no easier problem than problem number 11. If you miss problem number 11, you should walk away in great disgust of Shane's life. First of all, answer this question for me. What form is this? Eli? It's standard form. We've got two different forms we know. One of them is slope-intercept, where it looks like this. That's where you know the y-intercept and you know the slope. This is standard when both an x and y are on both sides. How do we solve things in standard form? We call it using what, Grace? X and y intercepts. You look for the places where it crosses the x-axis and the y-axis. How do I do that, Christian?
You cover up the x.
Exactly. If I cover up the x and put 0 in for it, if 3y equals 6, 3 times what number gives me 6, Lutz? That's where the y-intercept is, at 1, 2. I do the same thing to cover up the y. 2 times what number is 6, Christian? That's where it crosses the x-axis. 1, 2, 3. I got my 2 points. I draw my line all the way through it with a nice straight ruler, and I put my arrows there. 10 minutes, can I do it? It's a marathon. Solving for x. Okay, this is no different than if you would see this. 3x plus 2 equals 5. If I gave you that equation and told you to solve for x, you're going to follow the same procedures, it's just that you can't work with it as nicely. You need to get rid of the 2. And how do I get rid of that? Subtract it. Well, that's what I have to do with the b. The problem is this. B and C don't like each other, they don't get along, so you just have to go, okay, C, I'm just going to put a minus b next to it, because they're not like terms. Well, if I got rid of this 2 like that, and now I have 3x equals 3, how do I get rid of the 3 in front of the x? You divide it out. Well, that's what I do here. Divide out the a. it goes away, and I have to divide all that by A, and they don't like each other either, so that's all I do. I leave it as x equals C minus B over A. None of that combined, they don't go along, you can't put them together because they're just not like terms. 13! And then we'll probably go to 20 and work our way backwards. Same thing, the same rule for equations follows number 13, but right off the bat you should see one glaring thing that's going to cause you trouble, and that is this. You have a negative exponent, and that's not good with inequalities. Okay? But I solve it the same way. How do I get x by itself? How do I get rid of this 3? Subtract it over. Subtract it over. So now I get negative x is less than 1, but I'm not allowed to keep that. X cannot be negative. Here's the big note for this problem here. Christine, what has to happen here? This needs to be positive. And I can change it to positive, but what else do I have to do? You need to change everything else to its opposite. It's rhetorical questions. For emphasis, Christine, for emphasis. This becomes positive, this becomes its opposite, this becomes its opposite. Oh, and then graph it. So at -1, it's not a closed circle but an open circle, arrow's going to the greater than side, same as this, and it goes this way. This is what should stick out in your head. If that were positive, we wouldn't have had to do any of this flipping around. It would just meant x is whatever here. But if it's negative, opposite, opposite, opposite. I'm going to go to 20 because I saw a lot of people miss that one there. 20. How do you do 2 times the square root of 3 times the square root of 6? Michael?
I simplify the square root of 6.
Okay, and maybe for some of you maybe it would be better this way. I like what Michael did because it saved them a step. But you can multiply square roots together, and that's all you can do. You get 2 times the square root of 18, right? But we have to see if we can simplify the square root of 18, which means I have to try to factorize it. What times what gives me 18? Square root of 9 times the square root of 2. And the square root of 9 is the square root of 3 times the square root of 3. So I end up with a normal 2, a square root of 2, and 2 square roots of 3. What can I do with those? If you get a pair, Evan, you right, cross both of them out, you get a normal 3. No pair for the square root of 2, so it stays the square root of 2. You multiply the 2 normal numbers back together, and it's 6 times the square root of 2. 7 minutes left, I think I can do it. 14, you are to change 30 gallons per hour. The word per, children, is a fraction line. 30 gallons per 1 hour. I need to change it 2 times because I need to change gallons to quarts, and I need hours to minutes. It doesn't matter which one you do first, but you can only do them one at a time. You can't do it all in one step. So let's say I'm going gallons to quarts. How do I do that? Well, since gallons are on top up here, Alexa, they have to go.
At the bottom.
And I'm changing gallons to quarts, so I put my Q up there, and I need to know how many quarts are in a gallon. 4, Mr. Gallon's on the wall. Now I've changed it into quarts. Now I need to change hours into minutes. If hours is on the bottom here, Smith, it's got to go on top over here. And I need to know how many hours are in a minute or how many minutes are in an hour, and that is, Savannah, 60 minutes in 1 hour. And now my hours are gone. Here's my problem. You just need to multiply. 30 times 4 times 1 is what's on top, over 1 times 60 on the bottom. And you can do any cross canceling you like. 30 goes into 30 once, into 60 twice. 2 goes into 2 once, and into 4 twice. You got to remember your labels. What am I left with on top? Quarts. I'm left with the 2 on top. 2 quarts over minutes. 2 quarts per minute. 2 quarts per minute. 5 minutes, I think I can do it. If you're only as good at math as you were at lunch ball. This one here shouldn't have given you too much trouble. Your first step always in equations, and I think it just confused you with the decimal there. But these are both x terms, so you can put them together. What is 1x minus 0.5x? Or 1 minus a half, it's 0.5x. You take 1.0 and subtract 0.5 from it, you get 0.5. And that equals 1.2. How do I solve any equation like that? Ariel, I'm going to by 0.5. And you have to actually do this out. If the equation is in decimal form, please put your answer in decimal form. So it's 0.5 into 1.2, move the decimal, move the decimal. 5 goes into 12 twice, it's 10. 5 goes into 20 4 times, so it's 2.4. If the fraction's in fraction form, did I do it wrong? Grace? Yes. Yep.
How did you get 0.5? Because I thought x minus 0.5 is 0.4.
This is 1x. Anytime there's not a number in front of something, it's 1. 1.0 minus 0.5. Line up the decimals. It's like having $1 minus 50 cents. It's going to give you 50 cents. Okay. Same thing for equations. Can you see how many times equations come up on your test? I mean, if you know how to do equations, you're going to get most of the problems right. How do I get the x by itself? First thing I'm going to do, Calvin, is
Add 1/3.
add 1/3 because you do the opposite. Add 1/3, this goes away. If I add 1/3 to 2/3, I get 3/3. Now 2/3 x equals 3/3. Well, 3/3 is 1. And how many times do I ask you this question? If you have a fraction in front of a letter, what do you do to get rid of it, Michael? Flip and multiply. 1 times 3 over 2 is 3 over 2. And if you have 1 1/2, that's fine. Book just didn't use that there. 2 more in 2 minutes. Can be done, kids. Can be done. Let's do 18 first because it's probably the easiest. Please understand, adding like terms or combining like terms. Yes, these are all x's. Okay, but they have to be letters with the same exponents as well. And x squared is not the same thing as x. They're a little show-off-ishy. So you can only put 3x squared and take 1x squared away. That means you're left with 2x squareds. Here you have 2 x's, an x plus an x, and you're taking 1 away. Plus x goes away with the minus x, and you're left with just an x. Can't put those together, not the same. X squareds are not the same as x's. And the worst one here, 17. Oh, did we do 19?
No.
Oh, no. You want 19? Well, this one. Okay, let's do this one. 2 different parts because of addition subtraction signs not in parentheses. This and this become 2 numbers that you either add or subtract, whatever they end up being. This has no other signs in front of it, so it just stays a minus 2. This, please, here's where people go wrong on this. You have to do exponents first in order of operations. So the first thing you have to do is whatever's in front of the exponent. What's in front of the exponent? What's in front of the exponent? No. What's in front of the exponent? A parenthesis. And that means whatever's in the parenthesis is what you use the exponent to do. I have 2 negative 2's times themselves. And a negative 2 times a negative 2 is a positive 4. Now there's a negative outside of that, which makes it turn back to a minus 4. Okay. In the end, it should look like this. You have a negative times a minus 2 times a minus 2. 1, 2, 3 negatives means your answer is going to be negative. 2 times 2 is 4. Negative 2 and negative 4 is negative 6. You owe somebody 2, you owe them 4, you owe them 6. And last, but proverbially not least, somebody want to tell me what they did on this one? Easiest way to do this, in my book, Michael?
I wrote out all the letters, I put 2 X's.
Okay, that's one way to do it, but what did you do with this negative exponent? Okay, you wanna move it to the bottom. That'd be the first thing I would do. You don't like negative exponents, so I'm gonna take it from there and move it down here and make it a 1 there. And I'm gonna do what Michael said, and I'm just gonna write out all the letters by themselves. This is 4 times x times x times x, 3 x's, over 6 times x times x times x times x, x to the 4th, times y times y times y. Doing the numbers first, if you just reduce 4, 6, 2 goes into both of them, you end up with a 2 up there and a 3 down there. And now, same things on top, cross off the same things on bottom. This x with this x, second x, third x, no more x's on top, so the 2's by itself, you're left with 1x on the bottom and y times y times y, y to the 3rd on bottom. So 2 over 3x y cubed. That was test 17A, and about as fast as I could possibly do it. I always like to minimize just to look at it. And here's the deal, right now, I will put this, if you really want to study, I hope I pushed it